All right, here we are on objective 5.2, the practice test. Use triangle congruence criteria. So this is like ASA, etc. Triangle congruence criteria, transversal relationships, and related theorems to determine the measure of an angle in a support structure. So again, this is like ASA, AAS, etc. Transversal relationships, this is like corresponding angles. And related theorems, this is stuff like the isosceles triangle theorem or the triangle sum theorem, that triangles add up to 180 degrees. So basically use all the theorems that we know to determine the measure of an angle in a support structure. So you have sort of a structure that is supporting something. For example, this might be a part of a bridge or a building. This might be a cog in a machine that's being held together by four cross beams and a circle. So we're trying to determine the measure of each angle. Well, we always start with writing down what our given is in the picture. Level 1, given that AB is perpendicular, that's what that means, perpendicular to AC, find measure angle CDA. So we know that AB is perpendicular to AC, then we can put a right angle marker here and here. We need to find measure of angle CDA. So here's the question mark. If we need to find it, well, it's part of a triangle. Here's the triangle. Triangles have to add up to 180 degrees. So all three of those need to add up to 180. So far, we have 90, which is from there, and 61.2. Those add up to give 151.2. Well, we know the total has to be 180, so we just take 180 and subtract off the 151.2, and that means this has to be 28.8 degrees. So measure of angle CDA is 28.8 degrees. Explain your answer. Because triangles sum to 180 degrees. Given xz is equal to xy, meaning that these two pieces are congruent, first thing I do, given this, so mark it, xz and xy are congruent. Oh, look, I have an isosceles triangle. So those two are congruent. Whenever I have an isosceles triangle, I can always find the other two pieces of it if I have one of them. So this is 90 degrees right there. If that's 90 degrees, then the other two have to add up to the remaining 90 because the total has to be 180. That's 90, so that takes it away. And then the other two have to add up to 90, but they're the same. So if the same number adds up to 90, it's just 90 divided by 2, so they're 45 each. So that means each of these angles, 45 degrees. Those are both 45 degrees. So explain why angle XWV is 45 degrees. XWV, this one. Why is that 45 degrees? Well, it's all the way on the opposite side. But if we can just find a type of angle relationship, like corresponding or something, that connects them, then that would be good. Here, I see my two parallel lines. Remember that this marker means parallel. I see my two parallel lines cut by a transversal. Parallel lines, I'll do it in a different color. Parallel lines, transversal. Why am I using these lines in particular? Because I'm looking for that angle, and this angle is then part of that structure. Well, I'm looking at this and this. Those are congruent. Why? They're alternate interior. So you can say measure of angle XWV is 45 because it's alternate interior to angle WZY. This is WZY, angle WZY. So it's congruent to angle WZY, which is 45 degrees as it's in an isosceles right triangle. That's it. What are the two steps here? Figure out that these are both 45 because it's isosceles and has to add up to 180. Remember that, two steps. Find out that these two are both 45 because it's isosceles and adds up to 180. And then discover that this is congruent to this because they're alternate interior angles. That's why. Level 2, which is where we start to apply it in a couple extra steps. Given that CD is perpendicular to BC, so that's right here, 90 degrees. That's immediately going to tell me something. That immediately tells me what this angle is because they have to add up to 90 degrees. This and this have to add up to 90. Well, if they have to add up to 90, then this is going to be 90 minus it, which is 28.8. So that means this angle ACB, is 28.8. They also tell us that AB is perpendicular to AC. AB and AC are perpendicular, so I can put a right angle right there. Well, the whole triangle has to be 180. So 180 minus 90 minus 28.8. The result is 61.2. And so this angle is 61.2 degrees. Again, here's the chain of logic. This angle is 28.8 because it has to make 90 with this from this given. And then this angle is 61.2 because it has to make 180 with these other two angles. Given that AC is congruent to AD, all right, I'll start off. I always start off by marking what I'm given. DGE is 74. DGE 74 degrees. And they also tell us that GDE is 69 degrees. GDE. They tell us right here that it's 69 degrees. 69 degrees. Then I go for what can I immediately find, and they say how to solve for FEG, but so I'll put a question mark here. I'll go, what can I find immediately? Oh, this triangle is isosceles. So its other two angles have to be equal. These have to be congruent. So it's 180 minus 40, that's 140. That's to divide equally between two of them. So 140 divided by 2, 70. So these are each 70 degrees. What else can I do here? There's tons of other pieces I could go for, and I can go all over the place in finding each one of the angles. There's tons of different ways to do it. Here's my way, would be if this is 74 and this is 69, then I can find out this missing green angle right there by subtracting those two from 180. So let's do that. In red is going to be 180 minus 74 minus 69. This results in 37. So this is 37 degrees. Then the question is, what's FEG? And I think we have enough to figure that out now. We could do it a couple ways. Here's the total between those two. That corresponds to the total between those two. So that means that this question mark has to add these two up to 70. So question mark plus 37 is 70. Minus 37 on both sides, question mark is 33. So that means that the measure of angle FEG is 33 degrees. Written solution to explain yourself would be question mark is 33 degrees. Actually, we'll just We won't start with the answer. We'll start with how we started. Angle ADC, its measure is 70 degrees by the isosceles triangle theorem. That's basically using the fact that it has to add up to 180 degrees, and those two angles have to be congruent. Slash, so I guess slash TST, the triangle sum theorem. So you combine those two together to get the fact that these both need to be 70. Measure of angle GED is 37 degrees. That's this one. Because triangle GED sums to 180 degrees. So the leftover angle FEG must add to 70 degrees. Thus, measure of angle FEG is 33 degrees. And you can show your work up here as well. That counts as part of the explanation. Just part of it, though. If it says explain, you need to use words. Level 3, if you've mastered it, you can do this. You can apply all the different theorems and bring them together. So given that AC is congruent to AD is congruent to AE, boom, boom, boom. Measure of angle ADE is 20 degrees more than ADC. Well, I don't know what ADC is, so that's not helpful to me yet, but maybe it will be later. Find measure of angle EAD. Oh, wait, actually I do know what this angle is, because it's part of, guess what? It keeps coming up, an isosceles triangle. If it's part of an isosceles triangle, then I can find the other two angles. Some people might think, oh, this is going to be 64 again. Well, no, it's not, because it has to total up to 180. They can't all be 64 if they're going to total up to 180. So we'll do 180 minus 64, which is 116, and divide that by 2 to get 58. So each of these angles is 58 degrees. If those are each 58 degrees, let's go back to what we erase some of the extra things. Those are both 58 degrees. I don't know if there's anything else I can figure out, but oh, I can go back to the given. Measure of angle ADE is 20 degrees more than ADC, but we know ADC now. That's 58. What's 20 degrees more than 58? That's right, 78. Oops. So think about which of these angles is going to be 78. It says ADE is 20 degrees more than ADC. That makes this one 78. But look, this is an isosceles triangle also. Gotta be able to identify, look at all these isosceles triangles all over the place. So this is 78. So both of those corners are 78. 78 times 2, 6, 156. Well, the whole total has to be 180. Any triangle, no matter what. So the yellow triangle here, that's got to be 180. So the missing angle, which is what we were looking for, EAD. EAD, this angle. It's 180 minus 156, which makes it 24 degrees. Measure of angle EAD is 24 degrees. Done. What was the process again? This triangle is isosceles. Go back and rewind it if you want my process fully, but this triangle is isosceles and this triangle is isosceles. So they've got to have matching angles on the bottoms. And those matching angles on the bottoms and the fact they have to add up to 180 with their top angles is basically all we're using here. All right, last but not least, we are given AC is congruent to AD. AC and AD are congruent. Oh, so this is another isosceles triangle, just like we did above. So I'm immediately going to say these two are both 70. How do I know they're both 70? Because they have to add up to, well, 70 and 70 is 140. Plus the extra 40 is 180. So how do I know it's 70 specifically? Well, because I just take 180 minus 40, minus 40. Oops. 180 minus 40, that's 140. And then I divide that by 2. That gives me 70. Because the two have to be split equally. That's the isosceles triangle theorem. All right, we're also, I don't know if we can get anything else from this, so let's see what else we're given. We're also given that FD is congruent to FE. So this is congruent to this. Oh, it's another isosceles triangle. But look at what I actually covered this up, which I shouldn't have. This is parallel to this. If that's parallel, that means here, that's 70 degrees. So if this is 70, put that in red actually. If this is 70, and it's isosceles, so is this. Those are both 70-degree angles. And they say, wait, what? Shoot. Oh, there's a mistake in this problem. There's two ways to solve this. And I'll come back to you guys tomorrow and let you know what it is. But here's one way to solve it, and I'll show you the other way you could have solved it. This problem is what we call overdetermined. So if those are both 70, well then this is 180 for the total of all three, minus 70 minus 70, which makes it 40 degrees. The problem is we add this extra part, so we should really erase this, that we measure precisely that this is 42 degrees, because that's not really consistent. But let's say that we do measure that it's 42. So it's 42 degrees. If that's the case, then both of these angles don't need to be 70. They actually need to be 180 minus 42, 138. Divide that by 2. That's 69. So these are each 69 degrees. And if that's the case, then this must be 41 degrees. So I apologize, I actually just realized now that I'm making a problem that can be solved in two different ways, and that's not actually possible. So I would of course accept either one of these solutions, but it's actually good to analyze problems where they are overdetermined to see what the problem is. So I'll reiterate what that was. Here's the issue. You have two different things that these angles could possibly be. Because these lines are parallel, that means that this green angle and this green angle have to be congruent because they're corresponding. So that means that green angle's got to be 70. But at the same time, it can't be 70 because if this is going to be 70 and this is going to be 70, then that would make this have to be 40. But they say right here that it's 42 degrees. So unfortunately, it doesn't work there. Here would be the issue. You can only assume, I suppose, that this would mean that this is not a straight line. If that's not a straight line, then we can't use it as a transversal, which would make it so that we don't have the opportunity for this to be 70. We actually only get the opportunity for it to be 69 degrees because it's 42 and 42. So what we would have to show or include in this problem is an extra piece if we wanted to determine it, which is that CE is not straight. So really, if this is all the case, we're concluding that CE is not a straight line. But I wouldn't overthink yourself on this one. You can see all the different ways that you can solve it. This one is more indicative of what you're going to see on the test, as well as this one. So we've got all types of different problems. This one happens to be a problem that can be solved in 2 different ways, but not only in 2 different ways, has 2 different solutions. So it's not so doesn't really, either this figure doesn't exist, or in particular, that line ain't straight. But clearly it's supposed to be straight, so this is a screw up. So, don't always believe everything Mr. V does. Always go with a grain of salt, because I also make mistakes, especially when making these problems. All right, there's all the problems on objective 5.2. So there you go. Ask me any questions if need be.